Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 7 from the Smith Organic Chemistry textbook. And this problem gives us a little table about molecules A, B, and C. And so we're given some pieces of information for each molecule, and we're asked to fill in the remaining pieces of information. And so basically, the information we get is formula before hydrogenation, formula after hydrogenation, the number of rings, and the number of pi bonds in a molecule. And so for A, B, and C, we have some information for each, and we need to fill in what we don't have. Okay, and so I think that what we should do for each of these is to calculate the HDI, or the hydrogen deficiency index, for each one. And so remember, since we don't have nitrogens or halogens here, this is going to be pretty simple. HDI is going to equal 2 times the number of carbons plus 2 minus the number of hydrogens, and then all of that over 2. Okay, so for A, we have 10 carbons and 12 hydrogens before hydrogenation. So that's going to be 10 times 2 is 20, plus 2 is 22, minus 12 is 10, divided by 2 is 5. So our HDI for A is going to be 5. So that tells us that we have some number of rings and double bonds that adds up to 5. And so then when we look at the formulas, hydrogenating adds 4 hydrogens. So that's going to be 2 pairs of hydrogens. So that tells us that we have 2 pi bonds. And since our HDI is 5, we must then have 3 rings, because 5 minus 2 equals 3. Okay, so then looking at B, we don't have a starting formula, so we're not going to calculate an HDI for B. But our formula after hydrogenation is C4H10. We're told that we have no rings and 1 pi bond. And so our formula before hydrogenation is just going to be C4H8, because we have 1 pi bond. So we're just going to remove a pair of hydrogens from our post-hydrogenation formula to get C4H8. And so that's all of our information for B. So for C, we have C6H8. So we can calculate the HDI. It's always a good place to start. So it's going to be 2 times 6 equals 12, plus 2 equals 14, minus 8 equals 6, divided by 2 is going to equal 3. So we have 3 rings. We have a number of rings and double bonds that add up to 3. And so we have 1 ring, we're told. So we must have 2 double bonds. And so we're going to add 2 pairs of hydrogens when we hydrogenate. And so our formula after hydrogenation is going to be C6H12, because we've added 2 pairs of hydrogens, or 4 hydrogens total. Okay, and so that's all of the information in our table. Yeah, and so that's the way to approach this problem. I think we just need to calculate hydrogen deficiency index when we're given a starting formula, and then use that in conjunction with the other information that we're given to determine the pieces of information that we need to fill in. And that's the answer to chapter